Today's essential question is, how can you enlarge or reduce a drawing proportionally? Go ahead and write that down on your notes. Today we're going to be talking about scale drawings and models. So here it says, a scale drawing is a proportional two-dimensional drawing of an object. And then you have something called a scale model, which is a proportional three-dimensional model of an object. Could you think of an example of a scale drawing or a scale model? Some of you guys might have thought, well, a map is an example of a scale drawing. It's a smaller version of the real streets and roads out there. An example of a scale model could be something like a globe, which is a three-dimensional, smaller version of the Earth that we live on. Let's talk about scale. Here it says scale. The measurements in scale drawings and models are proportional to the measurements of the actual object. The scale gives the ratio that compares the measurements of the drawing or model with the actual measurements. So, for example, in a drawing, you might have something that is only 1 inch in distance, but in real life, that equals to 10 miles. So for the actual distance, you can write the scale as a fraction as so, or you can write it using the ratio colons, like this one here, which says 1 inch to 10 miles. Let's take a look at example 1. It says, what is the actual distance D between Cadillac and Detroit? Well, note something really important here. On the map and on any map that you'll ever read, you'll always see a scale. So here they have a scale of 1 centimeter to 50 miles. That means for every centimeter that you measure here on this drawing, that equals to 50 real miles. So let's go ahead and set that up as a fraction. 1 centimeter to 50 miles. And we're going to use a proportion to figure out the actual distance between Cadillac and Detroit. So here's Cadillac, and here's Detroit. Grab a ruler, and let's measure the distance between Cadillac and Detroit. So it is just about, it's supposed to be 3.5 centimeters. Let me fix my drawing so that it matches the example in your book. Oops. There we go. So it's 3.5 centimeters. Since we have our centimeters on top of our ratio, we're going to go ahead and put our 3.5 centimeters here. Sorry for the writing, guys. And then X is going to be the thing that we are solving for. So recall that when you are solving a proportion, you're going to want to cross multiply and then divide. So I know that 1 times X is simply X. And then if I were to multiply these two together, that means X equals 50 times 3.5. Okay, I need to then multiply my two numbers together. So 50 times 3.5. That's going to give me 175. So let's write that down. So I know that the actual distance between Cadillac and Detroit is going to be 175 miles. Okay, let's go ahead and box or circle our answer. Here's another example, finding a distance in a model. Here it says the liquid outer core of Earth is 2,300 kilometers thick. A scale model of the layers of Earth has a scale of 1 inch to 500 kilometers. How thick is the liquid outer core of the model? Well, again, let's set up a proportion. So always start with the scale that they give us. So this time it's 1 inch to 500 kilometers. And they do give us some more information that I can use to set up my proportion. So here it says the outer core of Earth is 2,300 kilometers thick. I see kilometers here on the bottom, so I'm going to go ahead and put the 2300 on the bottom as well. And I know I'm going to need to find x, so I'll use a variable here. Again, I'm going to cross multiply and divide to figure out my proportions. So 500 times x, you can write it as 500x equals, cross multiply diagonally, 2300 times 1 is going to give you 2300. Okay, now I need to isolate x. So to undo multiplication, I'm going to divide by 500 on both sides. And then x is going to equal, well, try it, 2,300 divided by 500 should give you 4.6. So, and here we're talking about inches, so this would be inches that we're going to label. We're going to also box or circle our answer. And here we have 4.6 inches in our answer. So if you think back and reflect, how thick is the liquid outer core of the model? Well, does 4.6 inches sound reasonable? It does for a model, right? If we had a really crazy large number or tiny number, then you would know to go back and check your work because it wouldn't make logical sense. Let's talk about something called the scale factor. So we don't need this anymore. I'm going to close this out. It says a scale can be written without units when the units are the same. A scale without units, let's go ahead and underline or circle that, without units, is called a scale factor. So example 3 says, finding a scale factor. A scale model of the Sergeant Floyd Monument is 10 inches tall. The actual monument is 100 feet tall. What is the scale of the model? And what is the scale factor of the model? So, first off, the scale is the easy part. That's the part that they give us already. So the scale, you can write as a ratio or a fraction. You would say the scale is 10 inches to 100 feet tall. Okay? You could also write that as a fraction. So you could write it as 10 inches over 100 feet. Okay? Now, this is the part that's going to be a little more complicated. Remember, what is a scale factor of the model? Scale factor has no units. So the directions here say write the scale with the same units. Use the fact that 1 foot equals 12 inches. That's pretty important. So we probably want to change everything to inches so that we can make everything the same units. So I know that 10 inches to 100 feet is my scale to start off with, right? But I want to make everything in inches. So I know that every foot has 12 inches. So if I multiply 100 feet times 12 inches, that's going to give me 1,200 feet. I'm sorry, not feet, because we just converted it to inches, right? So this needs to be inches. Now we can simplify this, right? One trick is you can always get rid of the zeros on the top and the bottom. Now I don't need the units anymore either, so let's go ahead and cross out the units. Because they're the same, you can cancel them out. So now we're left with 1 to 120. So the scale factor, which is always a ratio that has no units, but the units must be the same in order for you to get rid of the units, is simply going to be 1 to 120.